exercise 9.1 from the chapter Applications of Trigonometry. So in the first question, they're saying that a circus artist is climbing a 20-meter long rope, which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle marked by the rope with the ground level is 30 degrees. So this would be the diagram for the given information, where a 20-meter long rope is attached to the top of a vertical pole. So let's name the vertical pole A, B, and the 20-meter long rope would be AC. The 20-meter long rope makes a 30-degree angle with the ground, which is over here. They're asking us to find the height of the pole. So we know we need to find the opposite side to this angle, and we've already given the hypotenuse. So which trigonometric identity involves the opposite and the hypotenuse? So that would be none other than the sine 30. Sine 30 is the opposite over hypotenuse. So if we find sine 30, which is opposite by hypotenuse because of SOHCAHTOA, we can say that opposite by hypotenuse, opposite is AB, and the hypotenuse is 20. And we know that sine 30, the value of sine 30 is equal to 1 by 2. So using the cross multiplication, we can isolate AB in order to find the value of AB. So 2 times AB is equal to 20. And when we bring 2 over to the right-hand side, we will get AB is equal to 10. So the measurement of the pole AB is equal to 10 meters. In the second question, they've given that if a tree breaks due to a storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 with it, the distance between the foot of the tree to the point where the top of the tree touches the ground is 8 meters. We need to find the height of the tree. So they're asking us to find the original height of the tree, and since we know that the tree was broken in half, we need to find the original height of the tree would be the broken half plus the part that is still remaining, that is still fixed to the ground. So basically, the length of the tree here, length of the tree is equal to x plus y. So we need to find the value of x, and then we need to find the value of y. So first, we know the angle made by the tree with the ground is 30 degrees. First, let's find the value of x. So the value of x is the opposite side to the angle, and we know the adjacent side to the angle. So the trigonometric identity that deals with the opposite and the adjacent is tan. So if we find tan 30, which is opposite by adjacent, it would be x by 8, which is equal to 1 by root 3. So x root 3 is equal to 8, and the value of x is equal to 8 by root 3. Okay, next we need to find the hypotenuse. So we know the opposite side to this angle is 8 by root 3. We know the adjacent, which is 8, and we need to find the hypotenuse. So we can find cos 30, which is adjacent over hypotenuse, because they've already given us the value of 8 as the adjacent side. So adjacent over hypotenuse, which is equal to root 3 by 2, which is equal to adjacent, which is 8, hypotenuse, which is y. So root 3y is equal to 16. Y is equal to 16 root 3. So now they're asking us to find x plus y, which is the length of the tree. So we need to add x plus y. So x plus y is equal to 8 root 3 plus 16 root 3. Since they both have the common denominator, we just have to add 8 plus 16. We know that 8 plus 16 is equal to 24, so 24 over root 3. So let's rationalize this fraction. So when we rationalize it, we will get 24 root 3 over 3. 3 and 24 will get cancelled, so we will be left with 8 root 3, which is the height of the tree. In the third question, they've given that a contractor plans to install 2 slides for the children to play in the park. For the children below the age of 5 years old, she prefers to have a slide whose top is at a height of 1.5 meters and is inclined at an angle 30 degrees to the ground, whereas for the elder children, she wants to have a step slide at a height 3 meters and inclined to an angle 60 degrees to the ground. What should be the length of each slide in each case? So we need to find the hypotenuse for each triangle, and they've given the opposite measurement for each angle. So they've given the opposite side to angle 30 is 1.5, the opposite to angle 60 degrees is 3. So we need to find the hypotenuse. Let's name them x and y. So the trigonometric identity which deals with the opposite and the hypotenuse is sine 30. So if we find sine 30, which is opposite by hypotenuse, we will get 1.5 by AC, which is equal to 1 by 2. 1.5 times 2 is 3 is equal to AC, so the value of AC, or x, is equal to 3. Next, we need to find y. So we can do that by finding sine 60. We know that sine 60 is equal to opposite by hypotenuse, which is equal to root 3 by 2, which is equal to 3 by y. So root 3y is equal to 6. Y is equal to 6 by root 3. When we rationalize it, we will get 6 root 3 by 3. 3 and 2 will get cancelled. We will be left with 2 root 3. So the value of EC is equal to 2 root 3. In the fourth question, they've given that the angle of elevation of a top of a tower from the point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. We need to find the height of the tower. So they've given the angle and they've given the adjacent side measurement. We need to find the opposite. So we know that we can find the opposite and adjacent by using tan 30, which is h by 30, which is equal to 1 by root 3. h root 3 is equal to 30. h is equal to 30 divided by root 3. And when we rationalize it, we will get 30 times root 3 times root 3. We will get 30 root 3 divided by 3. 3 and 30 will get cancelled. So we will be left with 10 root 3. So h is equal to 10 root 3. In the fifth question, they've given that a kite is flying at a height 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. We need to find the length of the string, assuming that there is no slack in the string. So they've given the opposite side measurement, and we need to find the hypotenuse. So we can use sine 60, which is equal to opposite by hypotenuse, which is equal to 60 over x, which is equal to root 3 by 2. 120 is equal to x root 3. X is equal to 120 over root 3. When we rationalize the fraction, we will get 120 root 3 divided by 3. 3 and 120 will get cancelled, so we will be left with 40 root 3, which is equal to x. In the sixth question, they've given that a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. We need to find the distance he walked towards the building. So we need to find this distance. So let's name this triangle A, B, C. This would be D and E. We need to find DE. So first, we know that AF is equal to 28.5. So AF is equal to 28.5. So if we find tan 60, we will find EF. And once we find EF, we can also find tan 30, which would be AF over df, and when we subtract df from ef, we will get de. So let's also write that down. df is equal to de plus ef, and de is equal to df minus ef. So first, let's find tan 60. So tan 60 is equal to 28.5 by ef, which is equal to root 3. So 28.5 by root 3 is equal to ef. Next, let's find tan 30. So tan 30 is equal to 28.5 by df, which is equal to 1 by root 3. 28.5 root 3 is equal to df. So we need to find de. We know that de is equal to df minus ef. So de is equal to df, which is 28.5 root 3, minus ef, which is 28.5 by root 3. So in order to subtract this, we're going to make sure that they both have the same denominator. So we're going to multiply this by root 3. So 28.5 times 3, because root 3 into root 3 becomes 3, minus 28.5 by 3. Root 3. So 28.5 times 3 minus 28.5 is equal to 57. So 57 by root 3. So if we were to rationalize this, we would get 57 root 3 by root 3 times root 3. So we will get 57 root 3 by 3, where 3 and 57 will get cancelled, so we will be left with 27 root 3 meters, which is the distance he walked. In the seventh question, they've given that from a point on the ground, the angles of elevation from the bottom and the top of a transmission tower fixed at the top of a 20-meter high building are 45 degrees and 60 degrees respectively. We need to find the height of the tower. So the height of the tower is h meters, which is CB. So we need to find CB. And they've given that the building is 20 meters high. So in order to find CB, we can say that CA is equal to CB plus BA, and CB is equal to CA minus BA. So we need to find CA and BA and then find its difference. So first, let's find tan 45. So tan 45 degrees is equal to 20 by x, which is equal to 1. So the value of x is equal to 20. So dA is equal to 20. Next, let's find the value of tan 60. So tan 60 degrees is equal to CA by dA, which is 20 degrees, which is equal to root 3. So CA is equal to 20 root 3. So now we need to find CB, which is CA minus BA. So CB is equal to CA, which is 20 root 3, minus BA, which is 20. So we can take 20 commonly outside, so we'll get 20 times root 3 minus 1, which is equal to the height of the tower. In the eighth question, they've given that a statue 1.6 meters tall stands on top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees, and from the same point, the angle of elevation of the top of the pedestal is 45 degrees. We need to find the height of the pedestal. So we need to find the value of h. So first, let's find tan 45. So tan 45 is equal to h by CB, which is equal to 1. So h is equal to CB. Next, let's find tan 60. So tan 60 is equal to 1.6 plus h by CB, which is equal to root 3. So 1.6 plus h is equal to, since CB is equal to h, we can just substitute the value of CB instead of h. So we can write h root 3. So 1.6 is equal to h root 3 minus h. 1.6 is equal to h root 3 minus 1. 1.6 by root 3 minus 1 is equal to h. And if we were to rationalize this, we would get 1.6 times root 3 plus 1 by 2. And on the numerator, we would simplify 2 and 1.6, we will get 0.8. So the answer would be 0.8 root 3 plus 1. In the 9th question, they're given that the angle of elevation of the top of a building from the foot of the tower is 30 degrees, and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. If the tower is 50 meters high, find the height of the building. So we need to find h. So first, let's find tan 60. So tan 60 degrees is equal to 50 by BQ, which is equal to root 3. So BQ is equal to 50 root 3 by 3 when we rationalize 50 by root 3. Next, let's find tan 30. So tan 30 is equal to h by 50 root 3 by 3, which is equal to 1 by root 3. So when we write this in a proper way, we will get 3h by 50 root 3 is equal to 1 by root 3. So by cross multiplication, we will get either through cross multiplication, or we can multiply the second term with 50 so that they both have the common denominator. So we can get 3h by 50 root 3 is equal to 50 by 50 root 3, where 50 root 3 and 50 root 3 will get cancelled. So h is equal to 50 by 3, and when we write this as a mixed fraction, we will get 16 to root 3 meters. So in question number 10, they've given that two poles of equal heights are standing opposite each other on either side of a road, which is 8 meters wide. From a point between them on the road, the angles of elevation from the top of the pole is 60 degrees and 30 degrees respectively. We need to find the height of the poles and the distance of the points from the poles respectively. So first, let's find tan 30. So tan 30 is equal to h by x, which is equal to 1 by root 3. So h root 3 is equal to x. Next, let's find tan 60. So tan 60 degrees is equal to h by 80 minus x, which is equal to root 3. So h is equal to root 3 times 80 minus x. Since here we've represented x in the form of h, we can substitute that value here. So h is equal to root 3 times 80 minus h root 3. So when we multiply within the bracket, we will get 80 root 3 minus 3h, and when 3h is brought over to the side, it becomes 4h is equal to 80 root 3, and h is equal to 20 root 3. So now that we know the value of h, we can substitute it here in order to find the value of x. So x is equal to 20 root 3 times root 3. So x is equal to 20 times 3. 3 2s are 6, so 60. And the value of EB, which is this is the distance of one point from one pole. So from the first pole. From the second pole, it's 80 minus x, the distance. So 80 minus x would be 20, which would be the distance of the point from the second pole. In the 11th question, they've given that a TV tower stands vertically on a bank of a canal from a point on the other bank directly opposite to the tower. The angle of elevation of the top of the tower is 60 degrees. From another point 20 meters away from this point on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. We need to find the height of the tower and the width of CD and 20 meters from the pole AB. So first, let's find tan 30. So tan 30 is equal to AB by 20 plus CB, which is equal to 1 by root 3. AB root 3 is equal to 20 plus CB. Next, tan 60. Tan 60 degrees is equal to AB by CB, which is equal to root 3. AB is equal to CB root 3. So we can write CB is equal to AB root 3 minus 20, which is equal to CB. So we can substitute the value of CB in terms of AB here in order to find AB. So we can write AB is equal to AB root 3 minus 20 times root 3. So AB is equal to 3AB minus 20 root 3. So minus 2AB is equal to minus 20 root 3. AB is equal to 10 root 3. So the height of the tower would be 10 root 3. Next, now that we found the value of AB, we can substitute that here in order to find the value of CB. So 10 root 3 is equal to CB root 3. CB is equal to 10. So the width of the canal would be 10 meters. In the 12th question, they've given that from the top of a 7-meter high building, the angle of elevation of the top of a cable tower is 60 degrees, and the angle of depression of its foot is 45 degrees. Determine the height of the tower. So we need to find the value of h. So first, let's find tan 45. So tan 45 is equal to 7 by dB, which is equal to 1. So dB is equal to 7. So next, let's find tan 60. Tan 60 is equal to h by 7, which is equal to root 3. So h is equal to 7 root 3. So the height of the tower would be h plus 7. So 7 plus 7 root 3 is equal to the height of the tower. So taking 7 commonly outside, we will get 1 plus root 3, which is equal to h. So the height of the tower is equal to 7 times 1 plus root 3. In the 13th question, they've given that as observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degrees and 45 degrees. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. So we need to find x meters, which is the distance between the two ships. So first, let's find tan 45. Tan 45 degrees is equal to 75 by y, which is equal to 1. So y is equal to 75. So now that we know the value of y, we can find tan 30. So tan 30 is equal to 75 by x plus 75, which is equal to 1 by root 3. 75 root 3 is equal to x plus 75. X is equal to 75 root 3 minus 75. So 75 times root 3 minus 1 is equal to x. which is the distance between the two ships. In the 14th question, they've given that a 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees. We need to find the distance traveled by the balloon during the interval. So let's name this point A, this point D, this B, C, E, and now we know that this whole distance would be 88.2. Since the girl is 1.2 meters tall, this length would be 87. So first let's find tan 60. So tan 60 degrees is equal to 87 by CB, which is equal to root 3. So CB is equal to 87 by root 3. Next, let's find tan 30. So tan 30 is equal to 87 by CE, which is equal to 1 by root 3. So 87 root 3 is equal to CE. So they're asking us to find the value of BE. This is the distance the balloon traveled. And BE would be equal to CE minus CB. So BE is equal to 87 root 3 minus 87 by root 3 minus 87 root 3. So we multiply 87 root 3 times root 3 so that they both have the common denominator. So 87 minus 87 times 3 by root 3. And when we rationalize this, we will end up with 29 times 2 root 3, which is equal to 58 root 3 meters. So 58 root 3 is the distance the balloon traveled. In the 15th question, they've given that a straight highway leads to the foot of the tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. We need to find the time taken by the car to reach the foot of the tower from this point. So since they've given angle of depression, this would be 30 degrees and this would be 60 degrees. And since they're both parallel lines, using the alternate interior angles theorem, we can find this would be 30 degrees and this would be 60 degrees. So let's name this triangle BCA. And we're going to take AB as 6x, BC as TX. So we need to find the value of T. So first let's find tan 60. So tan 60 degrees is equal to h by BC, which is TX, which is equal to root 3. So h is equal to root 3 times TX. Next, let's find tan 30. So tan 30 degrees is equal to h by 6 plus tx, which is equal to 1 by root 3. So h root 3 is equal to 6 plus tx. Since we've already expressed h in the form of tx, we can substitute that value here. So we can write root 3 tx times root 3 is equal to 6 plus tx. 3tx is equal to 6 plus tx. 2tx is equal to 6. Tx is equal to 3. So the time taken by the car would be 3 seconds.